Hi. In this video, we would like to introduce the storage compute decoupling feature for OpenSearch clusters created in Huawei Cloud's Cloud Search service. This walkthrough has 3 parts. Data-intensive businesses in sectors like e-commerce and finance have long relied on a uniform storage architecture to manage all data. At the beginning, this architecture can get the job done. However, as data volumes start to increase exponentially, limitations begin to show. On one hand, it's difficult to balance performance and cost. High-performance SSDs come with a steep price tag, while more affordable HDDs simply can't handle high-frequency queries that require millisecond response times. On the other hand, the resource utilization is low. Historical data, which makes up the bulk of most data systems, consumes significant storage capacity but is rarely accessed to support high-speed real-time queries while lowering the cost of storing massive amounts of data. Huawei Cloud CSS introduces storage compute decoupling for OpenSearch clusters. It works by separating hot and cold data. Hot data that is frequently accessed is stored in high-performance storage media, while cold data that is infrequently accessed is migrated to low-cost storage media. Object Storage Service. The decoupled storage compute architecture for OpenSearch offers the following benefits. High-performance hot data queries. Hot data is stored on high-performance local disks, such as SSDs, enabling real-time queries with millisecond response times. Low-cost cold data storage. Cold data is migrated to OBS, where it can be queried with a latency of seconds to minutes, but long-term storage costs are reduced significantly. Automatic hot-to-cold transition. Custom index lifecycle policies can be defined to automatically move data from the hot tier to the cold tier. This is how storage compute decoupling works. Data write. Hot data is written to high-performance local disks, SSDs, to ensure real-time query performance. Hot-to-cold transition. Low-frequency data is migrated from SSDs to OBS, turning it from hot data to cold data. You can call the index freezing API to manually turn hot data to cold data, or define a lifecycle policy, for example, a 90-day data retention period, to have it triggered automatically. Cold data itself is stored in OBS for cost efficiency, but its metadata and date fields are maintained on local disks to enable rapid search. Query processing. Hot data is read directly from local disks with millisecond latency. For cold data, the system uses metadata retained on local disks to quickly locate it in OBS, load it, and return it to the user. We hope you find this video helpful. You can visit our help center to learn more.